Hello students, welcome to my physics class. Now today's discussion is Young's double slit experiment. Here you can see in the left side picture, S is the source and from there some wavefront are coming out. So the solid line and the dotted lines there are two types of wavefronts. Now the solid line is actually represents a waveform formed by connecting the points which are vibrating in same phase of crest, and the dotted line represents a waveform formed by connecting the points which are vibrating in same phase of trough. Now when these wavefronts reach to those two slits S1 and S2, from there secondary wavelets will be created. Now when the two crates of S1 and S2 are in same phase, actually constructive interference happens, and that is represented by that black circle you can see. And when crest for S1 suppose coincides with trough for S2, then destructive interference happens. Here it is represented by that red circle. Okay. So in the constructive region, the intensity will be very high, you will get the bright fringe, and destructive interference you will get dark fringe. Now when we in the last lecture we have seen what will be the intensity pattern. Now if we see the intensity pattern, the central pattern is bright fringe, then dark fringe, and all the fringes are of equal width. Okay, now here we want to find out the distance of a particular fringe from the central fringe. So how to do that? So for that, here if we consider the distance between the two slits S1 S2 is d, and the distance of nth fringe from the center is yn. Now if we do this simple derivation, I am explaining the steps here. So S1 p square, that is the distance from that S1 slit to the P point where we are considering particular fringe will be created. So that is S1 p square equal to d square plus yn minus d by 2 whole square, and S2 p square equal to capital D square plus yn plus d by 2 whole square. Here this capital D is the distance of the screen from the slit. Okay, now if you see here we are getting a term S2 plus P plus S1P in bracket into S2P minus S1P in bracket. And here if we have to do a consideration, we have to consider that the capital D is very greater than small d. That means the distance of the screen from the slit is very large. So in that case, this S2P and S1P almost equal to D, right? So S2P plus S1P will be 2D. And if we put that, the path difference S2P minus S1P will get YND by capital D. So this is the path difference, the wave coming out from S1 and S2 reaching to P. Okay. So now as we know that the yn is the distance of the nth fringe from the central right fringe, so we have to find out this yn. Now for constructive interference, what will be that yn, and what will be the form of the yn for destructive interference, we have to see that. Now in the last class we have seen what is the phase difference for constructive interference and destructive interference, and to find out the corresponding path difference we have to use this formula, that is delta phi equal to 2 pi by lambda delta x. Now we have seen for constructive interference delta phi is 2n pi, and for destructive interference delta phi is 2n plus 1 pi. Now if we use this, so at P point if constructive interference is satisfied, then path difference we can calculate delta x equal to S2P minus S1P, equal to n lambda, and if destructive interference condition is satisfied, then delta x will be s2p minus s1p n plus half lambda. Okay, so the distance of nth bright fringe from the center will be yn equal to n lambda d by small d. So the distance between two consecutive bright fringe will be called as beta, equal to yn plus n minus yn, that will be lambda d by d. Similarly, for dark fringe, if we calculate, it will be same, lambda d by d. Okay. Now, to get a sustained interference pattern, that means prominent interference pattern, we require these conditions. The first point is the sources must be coherent. That means the waves which are coming out from the sources has to be coherent. Now, coherent waves means the phase difference between the two or many interfering waves must be zero or remain same throughout time and space. Now, the second point is the interfering waves must have same frequency or wavelength. Otherwise, what will happen? We will not get sustained interference pattern, we will get a general illumination. The third point is the amplitude of the interfering waves should be equal or nearly equal. Now, what does this mean? So, we know that if we take the ratio of I max by I min, it will be like this: a2 plus a1 whole square by a2 minus a1 whole square. Now if it is equal, so that's why a2 equal to a1, so in that case it will be infinitely large. That means the maximum intensity will be very high compared to the minimum intensity, right? So that's why it is a prominent interference, sustained interference. Now the fourth point is the distance of the screen has to be at large distance so that the two slits are treated to be very close to each other. Okay, so this condition we consider in the last slide, the capital D is very greater than D. And the fifth point is interfering waves should be in same state of polarization. Okay, so these conditions has to be satisfied to get sustained interference pattern. So please remember this, it is very important. Okay, thank you.